morning, good afternoon. Miss Matei, Miss Slavnika are talking about finding the vertex of a parabola, of course, using the x-intercept. So let's get started. What do we have here, Miss Slavnika?
Well, simple question. What do we know about any parabola that can be graphed?
Okay, what do we know?
Well, one thing that I'm noticing about all three parabolas is that they are symmetrical curves. You can fold them along the axis of symmetry, and you can actually draw for each of them axis of symmetry that goes straight through the middle.
Something like that.
Something like that.
So it's
yes.
like I place a mirror that
Yeah.
goes exactly through the middle, or actually I don't like calling it middle, I like calling it
vertex.
the vertex. There you go. Okay, so the next one, the red one, where do I place my mirror?
Right
in
through the vertex. It's a vertical line that you can use as a folding line if you want to fold each parabola into two halves.
Okay, good. So, anything else I need to know?
Well, for now, what we need to know is that if we look at the green and the red parabola, we can see that these two parabolas are crossing x-axis.
Okay.
So the x-intercepts are,
in the case of the green one,
identical distance left to right from that vertical folding line.
Okay, so the first x-intercept, if I read my graph correctly, is 3, and over there is 7, right? So where is my vertex? My vertex will be exactly in the middle, so it will be, at least the x-coordinate will be
5.
How did you get that 5?
Well, if I have a distance 4 between 3 and 7, and I do, the left portion are 2 units, right portions are 2 units also, so it's a 3 plus 2 is 5, or 7 minus 2 is 5.
Okay, we don't really care about the y coordinate.
For now, no.
Okay, how about here? Hard to see, but I am assuming it's exactly the same.
Yeah.
The vertex will be halfway between the
x-intercepts.
So that tells me that it's extremely important for me to find my x-intercepts if they exist, right? The case of the blue parabola tells me that there are cases where the x-intercepts do not exist.
Okay. That's correct. So let's look at the first scenario, and we have an equation in the factored form, and we need to come up with x-intercepts. So how do we find it, Miss Matei?
Well, it's already factored here because it's factored. X-intercepts are those special points where y is 0, right?
That's correct.
I want to make my y 0, which means x minus 1 times x plus 3 equals 0, which means either x minus 1 must be equal to 0, or x plus 3 must be equal to
0 as well.
Okay, so my two x-intercepts are x equals 1 and x equals
-3.
-3. Good. Okay, so now how do I find the x coordinate of my vertex?
Simply averaging these two values, you will get the x coordinates of your vertex. And averaging means you add them together and you divide by 2. As simple.
Okay, so x vertex will be -2/2, which is -1.
That's
How
correct.
do I find my y?
Well, simply substitute this value for x in the original equation and calculate your y value.
So my x was -1.
Correct.
So -1 minus 1, -1 plus 3. So the y of the vertex will be -2
times
-1. Am I right?
That's correct.
So the vertex, the coordinates of the vertex are -1 and
-4.
There you go. I am done. Next.
Well, you have next equation. A little bit more work because we have to factor it first. It's not done for us.
Okay.
So hopefully our kids will remember how we factored trinomial. The first step, simply remove -1
Oh, you want me to remove? Okay, I can do that. I thought you wanted me to factor like that. Okay.
And if I look at the content of my bracket, we can factor that trinomial, finding two numbers that multiply together and you'll get -4. And when added together, you'll get -3. What are the numbers, Miss Matei?
I don't know, Miss Lanika. I don't know. That was a long time ago. Add. -4 and 1. Am I correct?
That's correct.
See, I got it. Okay, -4 and 1.
+1.
Okay,
So the
so
factored form of the trinomial is x minus 1 and x plus 4. No, x plus 1
x
and
plus
x minus 4.
There you go.
Okay. So now we have our x intercepts.
-1 and 4. So
now we need to find the average of these two.
Vertex -1 plus 4 divided by 2. So x vertex will be 3/2.
Yeah.
Okay. And how do I find my y vertex?
Simply go back to the original equation and substitute for x values.
And we're gonna leave our students with the y.
Absolutely. The guys in our classes and girls, they definitely can do that on their own.
Good. And that gives us a chance to look at the other example. I know what I need to do. I need to factor first. So 2 times -5, that's -10. I need two numbers. When I multiply them, I get. When I add them, I get. What do I get?
Well, I think that it's -10 and 1.
Wait, when I multiply...
If you multiply -10 times 1, you'll get -10. And if you add -10 plus 1, you'll get -9.
Why are these numbers useful?
Well, now we are looking into a decomposition method, and hopefully our kids remember how we did decomposition method in a previous unit. So we will split middle term into two terms, -10x and x. We will group this polynomial into two binomials, and we will factor both binomials separately.
X minus 5.
That's correct.
Look how lucky we are.
Yes, indeed, we are lucky because x minus 5 can be factored out.
No, Miss Lanika, we are not lucky. We know how to do this. 2x plus 1. There you go.
And now you just simply go back to solving for x-intercept. So x-intercept is 5, or the other x-intercept is -1/2. And one more time, you will average these two values.
5 plus -1/2 over 2. And we can
leave it for the kids to finish. Excellent.